Hey, welcome. This is the Boston.NET Architecture Group, and my name is Robert Hurlbut. And tonight, for us, we're meeting on a different night than we normally do. But for those of you who may be watching this video, it really doesn't matter. It's anytime that you want to watch it. But we have a special guest with us tonight. Bill Wagner is speaking to us on automating GitHub interactions and doing this securely and safely. This was a talk that Bill gave at a previous Boston Code Camp. Really enjoyed it and asked if he could deliver this talk to our group as well, which then you get an opportunity to watch. And so again, Bill, thank you for joining us, and I'll turn it over to you.
Alrighty, thank you very much, Robert. All right, so again, we're going to talk about GitHub Actions. Now, very briefly, a GitHub action is anything you can configure in your repository that runs in response to some trigger. Okay, so we'll talk about that. And basically, it's a way to go when something happens in your repo, some process starts and does some work. Okay, so they're very, very useful for doing a lot of things on GitHub and making GitHub a productive environment. All right, so briefly, what we're going to look at is we are going to come on. Sorry, there we go. PowerPoint froze. So, as we get started on the agenda, I'm going to start talking about what it means to operate in GitHub at scale. So, I'm on the .NET team in Microsoft, and what we are doing there is some of the largest and most active repositories on GitHub are running things in the .NET framework. The .NET runtime is there. Roslyn is there. Any of the anything in that nature is also there. Let's see if we can get this thing to wake up. And let's see. There it goes. Now it's back. All right. So we got some slides. So operating at scale and GitHub. Now I'm going to give you a tour of some of the automation that we use in different places on different repositories that we have. Some are code repos, some are the documentation repos, some are pretty much just spaces for us to store things. And we're going to talk a little bit about one of the most important concepts, threat modeling. And Robert here gives a lot of talk and does a lot of training on that. And what we mean by threat modeling is if a bad actor wanted to do something, what could they do in your repository? What could they do because you've enabled this automation? What possible bad things could happen? And then we're going to talk about some of the specific GitHub exploits that can happen because actions run in your repository. I'll give you some ways to stay safe. Again, it's not perfect. There are still things that can happen. And then we'll talk a little bit about some of the resources where you can read and learn more. Okay, so what do we mean by running GitHub at scale? This is just some of the things in our repositories over the past this is like for 1 month, I believe it was. Okay, so Roslyn is, for those that don't know, that is the repository that has the source code for the C Sharp and Visual Basic compilers. So in 1 month, merged 227 pull requests, 1,842 closed issues, 142 new issues came in. Some were valid, some weren't. 31 different authors were working in this repo in different pull requests in different ways to start PRs. Of those 227 merged PRs, over 433 commits and over 790 files changed. Now that's already large enough. But then when we get into uh, the runtime, which is even a larger version, let's go. Come on. Oh, I went one too far. Sorry. Okay, so in the runtime, 364 PRs, 325 closed issues, 1,367 files changed. Our docs repository, 403 PRs, talking about just what, you know, changing things for different things to teach people about .NET. 125 closed issues, almost 1,000 files changed. API docs, which is a bit of an outlier because the way the pipeline works there, which is one of our automation tools, is we will build things from the triple slash comments in the actual source libraries. Those get temporarily put here where we occasionally do some extra work in some of the namespaces. So for every new build, we will often end up with a PR that changes some 4,000 files that modify different monikers, different versions from an API to because the API reference is versioned. All right, so now what does that mean for us in our automation? Now, what to remember about our repositories, first of all, every single one of our source code repositories is multi-platform. So it runs on Windows, runs on x86 Windows, x64 Windows, runs on Mac, runs on x64 and in ARM, runs on a variety of Linux platforms, variety of different versions. So when a PR gets checked in, what we're going to do is we want to make sure that those changes didn't break anything and added the right features and the right content on all of those platforms across all of those different OSs and across all of those different versions. Now, as individual developers, that would make us very unproductive because you'd have to, find new machines, find new VMs, get started, do all these different things on all these different places. So instead, what we do is we have a lot of automations that start a build pipeline. So you'll make a source code change, you'll do the tests on your machine, so it validates at least on one platform, on one OS, and one version. Feel somewhat confident, and probably only run a subset of the tests because in repo like Roslyn, there are more than 20,000 individual unit tests. So you make a change there. Well, I'm going to run what I think are the affected tests, but the full suite takes, close to 20 minutes or more to run because it runs a lot. So then I'll open a draft PR, push it into GitHub, and say, now, in our automations, please run on all the different platforms and run all the tests and run the integration tests, and then let me know if there's something I should be looking at. And that will give me two things. One, if it all passes, I have a much higher level of confidence in my changes. And if it triggers some test I didn't run, now I know some of the tests or a test suite I should now run on my machine before I update my PR again and say, okay, this now really is ready to merge. All right, so GitHub Actions are stored basically as config files, more or less, um, in your repository. They're in a .github/workflows folder, and any file in that folder represents an action. And it will have several sections in it that will do things like trigger on a PR to do a CI build. It might trigger every day to do a nightly build. It can trigger when someone opens an issue and do actions like add labels. This is a new issue, or it can trigger when issues get closed or when a PR gets closed. There's some automation GitHub automatically has to parse it for fixes, comments, and close issues and so on. And these are all in in these config files. So what kind of things do we have? All right, so I kind of mentioned some of this already. We have CI builds in Roslyn, the runtime, that run in all these different configurations. 14,000 tests plus in .NET/runtime, 2,000 tests plus in the compilers. There are issue automation in that if you open an issue, it will do things like let's add triage labels. It will try to look to see, what components, what namespaces are you talking about. It will tag individual teams underneath the runtime to say you should look at this. It might tag the compiler team if it's in the Roslyn repo and so on. It will tag subscribers to a given area. We'll also add tags for community contributions because we want to prioritize things that come in from customers and from external people. We want to also tag PRs from them so we can recognize them when we do our release notes and say, hey, this was contributed by some of our public contributors. In Docs, we have a lot of different things that happen. So we have both content and code in the documentation repos. The reason we do that is we want to make sure that if somebody says, "Oh, I think you made a typo here in this code, I'm going to fix a typo," that doesn't introduce an error, right? So uh, if you've ever looked around inside the documentation repos, what you'll find is it's a mixture of Markdown that includes tagged C sharp, VB, or F sharp files or JavaScript files. And then there's also projects that run that code. Okay, so PRs that change code, if it changes any CS file, VB file, F sharp file, or a project file, or removes any of those, it looks to see what should get built um, in terms of what projects changed and will rebuild all those projects. And if no project exists and you like added a new source file and it's not going to get compiled, well, we error out your build so we don't merge that, right? So you should be adding something that is under our CI harness. We do the content build. The docs website, learn.microsoft.com, is actually a static site that gets built from Markdown. That's for performance reasons. There's some JavaScript that runs some things there, but much of the content is all static. So we're going to do the content build. That's going to do all kinds of build validations. It's going to do Markdown lint. It's going to do link validation. It does some other checks to make sure everything is, everything has titles, everything, variety of different checks around documentation. We also do issue labeling. So when an issue gets opened, fires off an action that looks and sees, what articles were you mentioning? We'll tag different labels there. We'll tag triage labels to say, well, somebody should look at this. So now there's a label that says someone on my team should look. We also have things where if somebody opens an issue and we need more information, we'll tag it with a needs more info label. And if the person who opened it just doesn't respond, well, it'll automatically close. And we also have labels that block merging in certain areas, right? We might be like, as we're prepping for a release, we work in the open. So you can see the docs we're writing for like today's .NET 10 Preview 2 release, but we don't want to merge that until the release is available for customers. So we have a label that blocks those. And then, we'll remove that label when we get told that the build is ready for download, and then we'll go ahead and publish. We also have Dependabot configured. And Dependabot, what that does is it is a built-in GitHub automation that looks at a variety of build files, whether that be for .NET, for Python, even NPM scripts and such for JavaScript, to look at dependency packages and so on. And what Dependabot does is it is tied into the feeds for a variety of package managers. And if any of your packages need to be updated, Dependabot will open a PR and say, this dependent package has an update. Here it is. And I'll open a PR. And then our CI build takes it from there and goes, well, there weren't any breaking changes, so you're okay. Or there were breaking changes in that particular build, so therefore the build failed, and we need to figure out what else we need to change before we take that dependency update. We also, because we have so many samples, we have a homegrown tool that was called the .NET Version Sweeper. And what that does is that searches all of our samples projects and flags any that are on a .NET version that's going out of support or not the current, either the latest current or the latest LTS version. And then we know to look at those and make updates there. We also have a what's new generator. So in Docs, we have one that every month we publish a page that says, here's significant changes in anything in our repo over the last month. So that looks at the history over the month, generates the page for us, then we can look at that and review it. And it also looks at any PRs that were made by community contributors and gives us a chance to recognize them. Again, that helps us operate at scale. The .NET/Docs repo, which is everything except API reference, has more than 5,000 different articles in it. So to know which ones were significant, it really helps to have the automation. And finally, we have things for a profanity filter, COC violations that will automatically close issues, automatically do something when people are misbehaving, which thankfully doesn't happen too often. And that's where we get into now what is what threat modeling, what things could happen because of GitHub issues. All right, or GitHub Actions. So now remember I said that a GitHub action is stored in a YAML file in your repository. And that YAML file then just either runs other actions, it can run shell scripts, it can run other command line commands like curl or the .NET CLI or anything else that's available on the container where it runs. So when GitHub starts your action, it's going to fire up a Docker container based on your config. It could be a Linux container, it could be a Windows container, and so on. And then it's going to install the things that you request in your action, and then run those commands. Okay, so and you can specify what actions or what writes into your repository and into any configured object related to your repository an action can have. So an action could you can specify even to be able to modify user rights. That is incredibly rare and probably really dangerous, but you could do it. So it's just another object. You could say, hey, this action has the rights to do whatever. So this is our first real scary part is a PR could modify those YAML files in your workflow directory. So someone could open a PR, they could just say, all right, I've just edited this YAML. I've given myself write access to your repository. And now my shell script is just going to make any kinds of edits or any kinds of things into your repo and now suddenly do things. Because it's got write access, it could then go grab write access wherever. And now the way they might exploit, we'll get to a little bit later. But so a PR can modify the action itself and make it do something different. Okay. Remember that I talked about some of the actions that we did, and many of those will run unit tests. They may run other bits to do integration tests, even if you wanted. May do some other build that shells out to some other things to possibly even do a publish or a deploy. So actions run and execute code. Okay. So when your CI build tests the changes in a PR, the CI build is going to run all the code in that PR. So anybody who made a change, they could make some malicious change in that PR. And then when they check it in, if you don't have any safeguards, you are running their code in a container that your account owns so that it has rights that you've configured into your account or your organization's account, depending on how your repo is configured. The distinction I make there is like in, say, the .NET repos, because it's a GitHub slash .NET slash whatever repository, that would be an organization repo. So you could have some rights into the organization. If it was in one of my personal repos, it'd be GitHub slash Bill Wagner slash whatever repo. That would only have rights to my account. Still not good, but a different scale, a different scope. Okay, so those are the two main kinds of things that a GitHub exploit could try to do. Because your action, everything that it's configured to do is just in a YAML file in your repo, a bad actor could modify that. Because your action probably runs some code that might be in your repo or might be somewhere else, that should also be checked to see whether or not that should run. All right, so now let's look at some of the specifics and what you can do to prevent this. All right, so one of the first things that I would want to do if I'm evil is, I'm going to write some code that just mines crypto because that way you spend your CPU resources and I get the money. So I'm going to inject this code into your library in some code that's called by some unit test. Okay. You've got pretty good unit test coverage. That's not that hard. And now I'm going to make sure the unit test passes, or it never returns because it's still mining crypto. And now I'm going to open the PR on GitHub. And now you start your unit test. It enters this infinite loop that's mining crypto and never leaving. And I'm going to now sell my newly minted crypto coins, delete my GitHub account, and disappear to my secret island. So that's one exploit there, right? I just simply don't change your actions. Don't think I may be doing something really crazy, but I'm just going to inject into your library some code that does something nefarious. All right, now, next I'm going to get even more evil. I'm going to be able to modify the action. Okay, I'm going to grant write access to the repo, including some contents, issues, pull requests. I can even modify settings if I want. Okay, now I'm going to update a shell script that's called by the action, or maybe even write my own new shell script and add it to the PR. And I'm going to post those secrets and tokens using curl. So here's where GitHub has some security, but it certainly is open to some exploits. When you run a GitHub action, one of the things that gets injected into the environment is a GitHub token. And that's a short-lived personal access token that will live for the amount of time the action is running. And that token is granted the rights that you configure in your action. Okay. If you look at the source of the action, if other secrets are needed, you may have said, okay, I need other secrets to run some of the things, and this is the name of those secrets. Now, GitHub is reasonably smart in that you can't write out those secrets to the console in an action. GitHub will automatically see what you're trying to do, and it'll replace it with, no, this action, this secret is configured, but you can't see it. And that's why I say I'm going to update a shell script called by that action to post secrets and tokens using curl. Because GitHub won't just print those out for me, so I couldn't just copy them out of the logs. But the environment has access to those secrets and tokens. So if I update the action to do something somehow, calling a script that calls curl, post those tokens and secrets to my website in some packet and some API that I understand that, hey, I'm trying to steal these secrets from your GitHub repo. Great, I now have them. They were stored on my server from my website where I sent them by curl. So now I've got this GitHub client app, uses token auth, and now it's going to go attack your repository. It's going to test your REST client, and now I'm going to just install it on some server. It's going to receive secrets and tokens from this modified script. I'm going to open a PR that runs that. I'm going to harvest the secrets. Okay. And then I'm going to run code that uses those increased rights to attack your repository. I'm going to leverage that exploit to get rich because now I may have compromised accounts. I may have compromised other settings. I may have stolen secrets that you use in other places. And I'm going to disappear to my secret island. Cool. Okay, now we're going to get just a little bit deeper. So what else could somebody do? If you look at a tour of GitHub Actions, there's a whole marketplace of useful actions on GitHub already. We use some of them. There's Markdown Lint, which just checks the validity of our Markdown. There are link checkers that if you're using Markdown in your repository, you can verify and check that all of the links work properly. There are things you can do to format code, do printy printers, to untabify, all kinds of different things. Now, so what would I want to do if I wanted to leverage that marketplace to be evil? Well, the first things I'd do is I would build a useful and reusable GitHub action. I'm going to promote it while I keep improving it so that I get adoption on it. Here's some cool stuff. Go ahead and use it in your repo and you find it useful. Now I'm going to add a real feature to this. And I'm going to say, this new feature is really cool, but I do need more rights to your repository. You've trusted me with read rights and some other things. Now I'm going to need to write. So you should be able to grant me those rights. And now after you start using that new version, you see it's okay. Now I'm going to create an exploit in a patch version of my marketplace app and go, you know what? I'm going to now use those increased rights that you gave me, and I am going to do something evil because that's just how I roll. After I've gained trust, I'm now going to exploit it in a more nefarious way. So now I'm going to merge my exploit into a release, and now you're using Dependabot, and if you don't have it configured safely, it's just going to automatically just grab a new version and say, hey, you know what? You got a new version of this dependency you're using. Let's just run it. And if you don't think through what could happen and do you want to update that version and that release, then what's going to happen is now you're running the version with my exploit in it. So now I could be grabbing secrets and I could be doing evil things. And then once again, as the nefarious actor, I'll disappear to my secret island. Okay, those are kind of the three main ways that someone can really can attack you via GitHub Actions. There's a whole lot of variations on those themes. You can try and get account rights. You can try and, hide it further, communicate with some other server to say you're going to send logs, whatever. You can do all kinds of different things, but they're kind of going to be based on one of those three themes. Either update something in the YAML or in the script itself, update your code itself that happens to be run by an action you already trust, or create some new or updated version of some dependency you're already taking from somewhere else. So now what are we going to do? All right, so let's talk now on the rest of this in terms of what are we going to do to try to keep your repository safe. Any of these things could be happening. So what we want to do is now let's harden as much as we can and keep as much productivity as we can. So the first most important tool that we use, and we do use these throughout the .NET org, is branch protection. So on any repository you have, you can specify any of the branches that are long-running branches like main or a particular release stream or anything like that. Anything that's not like just some, personal branch to do some work in for a while. And you can require everything goes through a PR. So if you go to any of our branches, any of our repositories, like even as a Microsoft employee who works on the docs every day, I can't just merge to main. I have to open a PR. It will be blocked otherwise. Okay, now to be fair, I have admin rights on one or two of the repos, so I could go change the rights, but that's it generally keeps us safe, and then by not going around those, we keep ourselves safe more safely. We can also set up branch protection rules to say that any of our CI systems has to pass before we can merge a PR. So if you open a PR and anything fails, nope, merging is blocked. Doesn't matter what else happens. Again, administrators can get around that if we need to. We can also require approval, and you can require any number of approvals. In docs, we require one. We usually figure if it's been reviewed, we're probably okay. But as a courtesy, we can tag more people and say we want more reviews, we want more feedback because this one happens to be big. In some of the code repositories, we also have one or two. And some of them have two, some of them have three in certain areas. We can also require specific approvals. So there's a file you can create in your GitHub repo that's called code owners, and that assigns ownership to any folder in your repository. And by configuring that, then you can say, everything under, say, async in the runtime is owned by Stephen Tobe, and unless he approves it, you don't get to merge there. So you can further limit it to say that anything requires a PR approval from the someone on the team in the specified code owners. You can have multiple people there. You can have GitHub teams there. So you can say this doesn't get through if it's a large repo unless the person who owns that spot or the team that owns that spot has approved it. Those things all do a lot to help. Okay, now the thing to remember here is that Write permissions is a trust relationship. As soon as you grant anyone write permissions into your repository, you are trusting them to be able to push things up there in certain ways, depending on what other safeguards you put in. So you want to also consider it really carefully and don't grant um, rights to people who shouldn't have them and audit them regularly. Your teams change over time. Different contributors who may have been really active in your open source project 6 months ago aren't anymore. It's always worthwhile to just occasionally look through there and see what you're doing, and who you've granted rights to. GitHub has also now added a new um, uh, classification of rights called triage, which is lower than right, but they can do some things if they're only occasionally helping you or they're not inside your organization, but they do help. And triage rights allows them to, you know, close some PRs. They can add labels. They can um, close issues. So they can help with some things that don't require pushing to the main branches. The other things that you can turn on, which we use different rules in different repos in the .NET repos for a few reasons. One, we can consider lash push approval on PRs. So in docs, for instance, what we'll often do for PRs from other teammates is we will say, okay, I'll approve this with about 4 or 5 suggestions. And once you take my suggestions, then you can merge. Or once you address my open questions, you can merge because they're not blocking. And that way it just keeps the back and forth a little simpler. What last push would mean is anytime I did something like that, what would happen is when someone then accepts my suggestions or makes edits and pushes those changes into their PR, my approval goes away and I have to reapprove because they've made changes. You can also make sure that PRs are blocked unless they're up to date with the base branch. Typically, as long as there's no merge conflicts, you're okay. But you may, in sensitive areas, say, I want to make sure that stuff is up to date and you have grabbed all the changes from base before we put those in. You can also consider multiple approvals, as I talked about a little bit before. Maybe you want 2 or 3 or more pairs of eyes there. Also, code owner's approval. Again, you configure teams that own different parts of your repository, and then you only allow those people's approvals are required before a merge can happen. We're also going to look at managing dependencies. So we can say that, all right, so only selected actions can run. So in the .NET org, in working in Microsoft, only actions that are defined in the .NET org are allowed to run because that's also just under our whole organization's umbrella. So we generally trust them rather than anything from the GitHub Marketplace. If something is in the marketplace, we have to specifically say, yes, it can run in this repo because we know it's safe. So we don't just say anything in the marketplace. We say only these 3 things that we've listed would be in our settings that we allow to run. And that we usually need some approval and some audit, especially if it's anything that needs more than read writes to anything in our repo. There's also something you'll see if you browse any of our repositories. We don't tag to a version or a tagged label like V1, V2.4, V7. We tag to a commit hash. Now that commit hash happens to match a version tag, but it's a hardened commit hash. If the owner of that repository deletes it, suddenly that action won't run because it's just not there. They also can't move. So like a v1.7 tag, the owner of a GitHub action in the marketplace could just move that and say, "Oh, I released a new quick patch update. I didn't update the version numbers. It's not that big." So the tag floats. Commit hashes can't. So it is an immutable. It's not a branch, it's not a version, it's not a tag. It can't move. And that way your dependencies don't get any updates unless you know about it. You will There's no, splat notation or anything. It's like it is this set of code, and that's the version we're running. And if we're moving it, we're going to go through whatever we need in order to make sure that that has been checked. We're also going to leverage Dependabot, so it'll notify you anytime anything gets updated. So change something, need something new, those things come into place. It can open PRs. As I said, it supports NuGet, NPM, most other package managers. It also supports the GitHub Marketplace, so you'll get notified if there's a new version. Then you can check the release notes, see what really changed, do any other validation you need to before you accept the updates. And it does slow you down so things don't happen automatically, but it is giving you increased safety. Now, then we're going to look at token permissions. So as I mentioned earlier, by default, the default GitHub token that gets handed to all repositories, you should definitely use that. You can configure it and put your own secret in that's your personal access token, but don't do that because then your action actually runs as you, and it could elevate rights based on what the action says to anything that you have or anything that you created in that access token. So that is a dangerous exploit. Always use the default GitHub token and set the permissions as low as you can so that the action actually runs. You can also set it different for different jobs in an action. So if it does step one, just needs read. Step two doesn't need anything. It's running locally. It's got none. Step three, it's writing status checks. So I can write status checks, but I can't do anything else. And be explicit about setting the required permissions. If you don't set anything in a GitHub action and you don't specify a permissions block at all, then it defaults to read and read everything. So it could read your list of maintainers. It could read all the issues. It could read all the content. It could read the PRs. A lot of things that maybe it doesn't need. So only grant the required permissions, even the explicit read permissions. And then it's like you can only read content. So like I mentioned, the one that updates, like our CI build, for instance, only needs to read the PR and read the content of the code. Doesn't need to do anything else. So it has read content permissions. It can't even read issues. It can't read user profiles, nothing else. Just reads the content. And as soon as you explicitly grant any permission, anything you didn't grant is turned off, even if it's normally on by default. So as soon as you set anything explicitly, you've automatically made yourself safer. Now, this is an advanced one, and I'll also give the real simple answer, which is always run in forks, which is the pull request as opposed to pull request target. So here's how this works is a little bit subtle, but it has very serious implications. If you run a pull request trigger, that means, and I'll pick on Robert. Let's say Robert submits a PR to us and it's in his fork because he doesn't have any write access to our repos. So, Robert Hurlbut / runtime has some code in it. If our runtime action runs on the pull request target, what it does is it checks out Robert's fork, merges in the changes from our base branch, and runs the action in the context of Robert's fork. So if he tries an exploit that tries to write in the action, it's actually going to write in his fork. It doesn't even really see that the base repository exists. And that's safer, right? So if people want to exploit themselves, have at it, right? It's kind of not your problem. So the pull request is noticeably safer than pull request trigger. But now let's say that what you do on a pull request has to update something in your source. Maybe even it's updating log actions or something. Then that becomes pull request target. And the way that would work, if Robert had opened a PR, is our base branch and repository is here. So now I'm going to merge in Robert's changes and run it in the context of our base repository. Now, what that means is any exploit he's created over here now gets merged in and is running in our environment. So that means any write access or any further access that it gets is in the context of the base. So that is noticeably more dangerous. Now, GitHub created the GitHub target one because there are a few select things that need it. But unless you absolutely really, really need it, don't use it. Now, what this does mean for us is anytime I'm trying to do something to test changes to one of our actions, instead of working in my fork, I have to work and create a feature branch in our base repository because then I'm working in the same context. So I could only do that if I have write access. And what it does mean is anybody who's trying to update our actions has to be someone with write access in our repository, or they really can't test it until we merge it, which is, which means you shouldn't be playing there anyway. So that distinction is one that's important. And the shortest thing to remember is just always use pull request rather than pull request trigger. It's safer. Or pull request target, excuse me. Then finally, be careful with trust. This is one that we've turned on in all of our repos pretty much universally. So if you submit anything to one of our repositories, you will see that a number of the actions don't run until someone with write access in that repository looks at the changes and goes, I don't see anything nefarious here. I will approve and run all the configured actions. Okay. Now, there are three ways that you can configure that. You can configure it to just go ahead and run all actions, which I would never recommend. It's very dangerous. It means anybody submits anything, anyone anywhere in the world submits a PR, it's going to run all your actions as soon as they submit it. You won't even have time to stop it or slow it down. There is a second one that was really popular for a long time, but is an exploit that is called, that they say require approval for first time contributors. So if someone has never submitted to your repository, their first PR you'll need to look at, review it, and then approve running actions. And if you merge that PR, subsequent PRs from that same person or that same GitHub account do not require approval. They will run automatically. That's a nice way to reward contributors because once somebody's been there and done something, you hope that they're going to continue to be good citizens. But it does leave you vulnerable to a wolves in sheep's clothing exploit where someone can say, here's my first PR. It fixed a small bug, but, I hope you'll take it. And then once you do, now they can do something more evil and you won't be required to approve running your actions before their exploit runs. So that's where in any of our product repos, we've set everything so that no matter how many really useful PRs you've given us, the actions won't run until someone looks at it and approves it. So that where you see a little back and forth occasionally is you might see one of us say, okay, this really looks good. I'm going to merge. I think I'll merge this. I'll approve it to run the actions. Oops, the CI build failed. Here's some errors you have to take care of. Then we'll merge it. And we may even dismiss the review at that point because we're going to want to look at it again anyway. And especially because we'll need to approve it to run the actions again after their next push. So that one, again, it slows you down a little bit, but it slows you down with the intent of making you safer. It puts a human in the loop. If I look at a PR and someone's changing our YAML files that configure actions, if it's not changing something that you wrote and you're explaining to me why, and I know who it is, I probably won't even approve it. If it's adding a shell script to one of our build scripts, I'm like, why are you doing this? And probably just don't even approve it before anything runs. So it'll just get closed. Now, some things to look at. Finishing up here. If you look at github.com/OSSF/scorecard, this is a project run by the Open Source Security Foundation. It is their scorecard project. You can point it at any of your repositories, and it will do a bunch of analytics and give you a score. You'll note that you'll have to trust it in order to do that. Do a little bit of due diligence, but they are generally They've been very reputable in helping to improve security in open source projects. So if you start there, that'll give you a lot of details on anything that you can and should change in your repository to make it safer. So see what kind of a score you get there. If you look at docs.github.com/actions, that is their actions documentation landing page. You'll get a lot more details on a lot of the things I was talking about tonight about what goes in that YAML file, how actions run and execute, how the context gets built, and so on. If you look at understanding GitHub Actions, the next link, that is a really good general overview of a lot of the things I talked about tonight. Here's how it runs. Here's the different triggers that you can use. Here is when stuff happens. Here's the kind of rights that you can deny or allow. And then finally, if you look at the marketplace, you can see the rich ecosystem that is there. And again, I don't really want this talk to just scare people away from using them. There is a tremendous amount of useful actions there. And GitHub does some due diligence on the marketplace. Again, you should do your own as well. That's just layered security. And that is the bulk of where we're at. And again, GitHub Actions do a lot to automate things in a repository. They do a lot of things that can make you more productive, but you're going to have to crank dials down as you look at what potential risks your repository has and what you need to do to try to minimize those to a level that you're comfortable with. And that is pretty much it, Robert.
All right, Bill, thank you very much. Does anybody have any questions?
I just want to say that was very helpful and like kind of scary. Like I didn't realize there were so many ways that you could be unsafe. So thank you for that. That was very eye-opening.
Well, but I hope it helped.
Yeah, definitely.
Thanks. Thanks, Craig.
Very good. Okay, well, thanks, Bill. We're going to go ahead and close the recording.